What if everything we thought we knew about the moon was wrong? What if it didn't take millions of years to form? Shocking new evidence suggests that the moon might have come into existence in just a few hours, yes, hours, following a colossal cosmic explosion. It all started when a planet-sized object named Theia slammed into Earth with unimaginable force. This wasn't just a simple crash, it was an event of epic proportions that sent molten rock, debris and vaporized elements shooting out into space. That explosive chaos, it turns out, may have led to the moon's sudden and violent birth. For decades, scientists believed a slower story. According to the traditional theory, when Theia collided with Earth, it created a swirling disk of debris. This thick cloud of molten rock, over millions of years, gradually cooled and clumped together, eventually forming the moon. But this calm and orderly process has started to fall apart under scrutiny. There's one major problem. If the moon came mostly from Theia, it should look chemically different from Earth. Yet, moon rocks brought back by astronauts show the opposite. They're surprisingly similar to Earth's own composition. And that's raising big, uncomfortable questions. This mismatch between theory and evidence opened the door to a bold new idea. What if the moon didn't take eons to form, but instead came together almost instantly? What if, rather than slowly clumping over millions of years, the moon was born from the chaos just hours after Theia's impact? It sounds wild, but the more scientists look into it, the more it seems to make sense. This revelation is shaking the very foundation of planetary science, flipping long-held beliefs upside down. And we're only scratching the surface of how deep this rabbit hole goes. Let's rewind for a moment. The old model said that after Theia's crash, debris circled Earth in a dense, hot ring. Over a long time, this ring cooled and compacted into the moon we know today. But again, if that's true, why are lunar rocks almost identical to Earth's crust? Data from the Apollo missions clearly show that the moon and Earth share nearly the same chemical fingerprint. That shouldn't be possible if Theia was a totally different celestial body. So scientists went back to the drawing board and ran fresh, more advanced simulations of the original impact. What they found was staggering. These simulations showed that the impact was far more intense than previously imagined. The force was so extreme that parts of Earth's outer layers, its crust and mantle, were completely vaporized. This material didn't just float gently into orbit. It formed a blazing hot, glowing cloud of vaporized rock and metal that stretched into space. And instead of taking ages to cool and form into a moon, this cloud began clumping together astonishingly fast, within just a few hours. A new moon started forming almost immediately, held together by gravity and heat in an explosive reunion. This idea changes everything. Instead of waiting eons for tiny particles to merge into a solid body, the moon could have been pulled together rapidly, possibly in just a single day. Its chemical makeup backs this up. It's simply too similar to Earth to be made mainly from Theia. And the moon's orbit, strangely perfect and stable, also hints at a rapid formation. If gravity took over right after the impact, it would explain why the moon settled into such a synchronized dance with Earth so quickly. We may be looking at a celestial miracle that happened in the blink of an eye. If all of this holds true, then the moon's formation story needs to be completely rewritten. It's not just an academic debate. It changes how we understand the evolution of the entire solar system. Could other moons have formed the same way? What about the planets themselves? If massive impacts like Theia's were common in the early solar system, then our current models may be missing something huge. These cosmic collisions might have played a much bigger role in shaping the worlds we see today than we ever imagined. It's a mind-bending possibility. And it doesn't stop there. The moon still holds secrets that we're only just beginning to uncover. Despite all the rocks we've brought back and all the studies we've done, it continues to surprise us. Its strange surface features, its mysterious interior, and especially its chemical connection to Earth, all suggest that something extraordinary happened in its past. That connection should have been a bigger red flag from the beginning. The moon is too similar to Earth to be coincidence. If most of its material really did come from Earth, then its formation must have been fast, violent, and unexpected. Now picture it. Right after Theia's collision, Earth's surface turns into a storm of molten vapor and debris, glowing with unimaginable heat. In space, a giant cloud of this material swirls chaotically, forming a fiery halo around the wounded planet. And then, just hours later, gravity takes charge. This cloud begins to cool and condense. Bits of debris collide, stick, and gather rapidly. The moon is born, not over a geological age but in what's practically a cosmic instant. It's a birth story unlike anything we were taught, and yet it might be far closer to the truth. That rapid formation may also explain a lot of the moon's unique traits. Its density for one is unusual. Its crust is incredibly thin. Some volatile elements that should have been present for longer periods are simply gone. All of these clues point toward an extremely fast and high-energy event. A slow-forming moon would have had time to trap more elements and form a thicker shell, but our moon doesn't show that. The evidence keeps pointing in the same direction. Something extraordinary happened in a very short window of time. And the orbit? It's oddly perfect. The moon's distance from Earth, its tilt, its influence on tides, all of it works together in ways that feel almost too precise. That precision suddenly makes sense if the moon formed rapidly and locked into orbit right away, instead of drifting into place over millions of years. These strange details no longer seem so strange in light of the new theory. If we accept that the moon formed fast, everything else starts to fall into place like puzzle pieces. So if that theory is right, it could mean that other moons and even some planets might have formed under similar circumstances. High-energy impacts might not just be chaotic accidents, they could be the universe's way of building new worlds. Our entire understanding of how planets and moons come together would need a dramatic overhaul. And at the center of this revolution is our very own moon, a relic of chaos, forged in fire and pulled from the edge of destruction into one of the most perfect orbits in the solar system. Why is the moon's crust so unusually thin? Why does it orbit Earth at such a tilted angle, almost like it's out of place? And why is its interior still partially molten after billions of years? These aren't just minor quirks, they're deep cosmic mysteries. But under this new high-speed impact theory, things begin to make a lot more sense. If the moon really formed in a matter of hours, rather than over millions of years, it wouldn't have had time to cool and settle in the way scientists originally assumed. Instead, it would be a leftover relic of a cosmic-scale disaster, bearing the physical scars of a catastrophic event that reshaped both the Earth and Moon forever. However, before we go rewriting every science textbook and declaring this theory as the new truth, there's one major issue: it still needs more evidence. As exciting and revolutionary as this new model is, science doesn't move on speculation alone. That's where NASA's upcoming missions, like the Artemis program, step in. NASA wants to get their hands on lunar samples not just from the surface, but from deep beneath it. Surface dust has already been studied thoroughly, but if this theory is true, the real secrets lie buried under layers of untouched rock, layers that haven't been disturbed for billions of years and could hold the proof we're looking for. But digging into the moon isn't exactly a walk in the park. This isn't a quick science fair project. It's one of the most ambitious goals of future lunar missions. Getting to those deep rock layers means sophisticated tools, advanced robotics, and a mission that could take years to execute. Yet the reward could be monumental. If those buried samples contain the same material predicted in current computer simulations, it would be game over for the old theories. We'd finally have our smoking gun. Undeniable proof that the moon formed in an instant from Earth's own material, flung into orbit by a violent impact that left both worlds permanently changed. Now imagine what that truly means. Earth itself, our home, was transformed in a matter of hours. And the moon, that bright companion in our night sky, isn't just a random lump of rock floating nearby. It's a piece of us, a literal chunk of Earth ripped away and thrown into space by forces almost beyond imagination. As we uncover more about the moon, we're really learning more about Earth's own history. These two bodies have been locked in a cosmic dance for billions of years. And if this new model proves accurate, it means we've been interpreting that dance all wrong since the very beginning. The traditional theories of lunar formation are beginning to crack under the weight of new data. For decades, scientists were confident in the slow formation model. But now, with modern supercomputers and advanced simulations that ignore our old assumptions, the numbers are telling a different story, one of violence, speed, and cosmic chaos. But this story doesn't end with the moon. In fact, the entire solar system is full of strange, unexplained events that continue to puzzle scientists even today. The moon's mystery may just be the beginning of a much bigger unraveling. Take Venus, for example. It's the second planet from the Sun and often called Earth's twin due to its similar size and mass. But this twin has a rebellious streak. Unlike every other major planet in the solar system that spins counterclockwise when viewed from above, Venus spins the opposite way. No one can say for sure why. Some suggest it was flipped by a massive impact, while others think its thick atmosphere might play a role. But whatever the cause, something extreme happened. Something so powerful it made an entire planet spin in reverse. Then there's the mysterious Planet 9. Scientists have noticed that objects in the outer solar system, far beyond Neptune, move in strange and unexpected ways. They don't follow the gravitational patterns we'd expect unless, just maybe, there's something big lurking out there. The leading theory? A giant, undiscovered planet much larger than Earth is pulling these objects with its gravity. But despite years of searching, no one's actually seen it. Is it hiding in the darkness, too far to detect? Or could there be some entirely different explanation that challenges our current understanding of gravity in space? Speaking of strange regions, the Kuiper Belt, a ring of icy bodies beyond Neptune, presents another bizarre mystery. For some reason it just ends. This abrupt boundary is known as the Kuiper Cliff. Scientists don't know why space suddenly goes from crowded to nearly empty. One idea is that a hidden planet might have cleared out this region. Another possibility is that the solar system's formation simply didn't spread materials that far. But right now it's all guesswork. Until we find more data, the Kuiper Cliff remains an unexplained void on the edge of our celestial backyard. Even farther out lies something even more puzzling, the Oort cloud. It's believed to be a vast, spherical shell of icy objects surrounding the entire solar system. Scientists think it exists because of how long-period comets behave when they suddenly appear in the inner solar system. But here's the kicker. No one has ever actually seen the Oort cloud. It's too far away, too faint, and might only be a theoretical construct. If we could confirm its existence, we might finally understand where comets come from, and how our solar system's edges were sculpted over time. Even our sun, the center of everything, still baffles scientists. You'd think we'd have it all figured out by now, but one of its biggest mysteries remains unsolved: its corona. That's the sun's outer atmosphere, and oddly enough, it's way hotter than the sun's surface. That's not how heat should work. In most cases, the farther you go from a heat source, the cooler it gets. But the sun breaks that rule completely. Scientists think magnetic waves or sudden energy bursts might be responsible, but no one has a concrete explanation yet. And that's not the only strange thing about our star. The sun's magnetic field flips every 11 years like clockwork. But why? What causes this cycle? Why are some flips weak while others are powerful enough to disrupt satellites and power grids on Earth? These questions remain largely unanswered. The sun, despite being right in our cosmic front yard, continues to hold its secrets tightly. Over on Jupiter, the Great Red Spot, a massive storm bigger than Earth, has raged for centuries. But recently it's been shrinking. No one knows exactly why. Is it finally dying after all this time? Or is it just evolving into something new? This raises a deeper question. How do gas giants like Jupiter even maintain such massive storms for so long? The answers are still out of reach, and Jupiter's stormy heart continues to puzzle planetary scientists. Then we come to Saturn with its stunning rings, one of the most iconic sights in our solar system. They look ancient, like they've been there since the beginning of time. But recent research suggests they might be surprisingly young. Some theories say they're remnants of a moon that got too close and was torn apart. Others believe the rings formed alongside Saturn. Whichever turns out to be true could completely rewrite our understanding of how Saturn evolved, and how violent its past may have been. Uranus is another planet that refuses to play by the rules. Its tilt is so extreme that it essentially rolls around the sun on its side. This causes each of its poles to experience 42 years of daylight followed by 42 years of darkness, a seasonal cycle unlike any other. Most scientists think Uranus got knocked over by a massive impact billions of years ago. But again, there's no solid proof. Just another cosmic mystery waiting to be solved. And then there's Neptune's moon, Triton. Unlike most moons, Triton orbits in the opposite direction of its planet's rotation. That's a major red flag. It likely didn't form with Neptune but was captured from the Kuiper Belt. But how was it captured without being torn apart by gravitational forces? What event allowed it to stay intact while being pulled into Neptune's orbit? No one knows. It's one of many clues that something strange happened in our solar system's distant past. The asteroid belt between Mars and Jupiter is another enigma. It's full of rocky debris that never quite formed into a planet. One theory is that Jupiter's gravity disrupted the process. But even that idea leaves holes. Understanding why the asteroid belt exists, and what stopped it from becoming a full-fledged world, could unlock answers about how planets form in the first place. Mars is another big question mark. It used to have rivers, lakes, and maybe even oceans. Now it's a dry, dusty wasteland. What happened? Most scientists agree that it once had a thicker atmosphere that held in heat and water. But over time, something stripped it away. Was it relentless solar wind? Giant impacts? A failing magnetic field? The exact story of how Mars lost its habitability is still incomplete. Even Mercury, the smallest planet, is a puzzle. Despite being tiny and having a slow rotation, it has a surprisingly strong magnetic field. That doesn't make sense under our current models. On Earth, the magnetic field is driven by a fast-spinning molten core. But how does Mercury, which is barely spinning and much smaller, generate such a powerful field? The answer remains elusive. And then, some of the weirdest mysteries happen close to home. When spacecraft perform gravity-assist maneuvers around Earth, they sometimes experience small but unexplained changes in speed. This is called the flyby anomaly. It defies current physics models. Some think it's a calculation error. Others wonder if it hints at unknown forces or dimensions. A similar case is the Pioneer anomaly. Spacecraft like Pioneer 10 and 11, launched in the 1970s, started to drift off their expected trajectories as they moved farther into space. One theory is that heat radiating from the spacecraft caused this. But again, there's no final answer. Even the process of planet formation itself is still under debate. Current models suggest planets form from spinning disks of gas and dust around young stars. But some exoplanets break the rules. Why do gas giants form so far from their stars? Why do some orbit in elongated, stretched-out paths that defy logic? These questions challenge the foundations of planetary science. So, could scientists have been wrong this whole time? Was the moon really created in just a few hours, not eons? Or is there something even bigger, some deeper cosmic truth, that we haven't uncovered yet? Let us know what you think. And if you enjoyed this dive into cosmic mysteries, make sure to like, subscribe, and stay tuned, because space isn't done surprising us.